that's the battery. Oh!
The first one was closed. Why? Because the battery started to limp, or
No, this is like the emergency turn off so that it doesn't crash. It just
this one
landed.
is fine. Okay, you reached the airport. Now put the duck on there. That's okay. So Ducky survived. It still looks okay.
Yeah, so the design is actually pretty straightforward. It is the same state machine that you've seen yesterday. So the main three systems that we have is our drone. We have our state machine, which I will just for now call controller.
Yes.
But it is implemented using a state machine. And then we have our vision, which is implemented using OpenCV.
We have the Dakibot, which let's mark it like here, and it builds the map.
This intersection is tricky during the daytime because we have the sun.
Yes.
And there are a lot of white lines that he messes up with.
Okay. Right, but let's wait. If you see in the next.
It's gonna make the left turn. I saw the locks.
Yeah, then it's good. You're locking out. And do you know where the airport is?
Yes.
Yeah.
Okay.
The airport is fixed.
All right.
But we have a code in case we want to have a random scenario where
Yeah.
we don't know.
As you see, we didn't ask for the random. It can be. But let's see. It should find the airport. No. Let's see. Okay. Good.
Oops. Checks for pedestrians.
Okay. And then this drone should go from here to there. Okay. What happened?
So the main problem was that we lost connection to the. So we got a lot of interference frames for some reason right there.
Because we were standing here?
Maybe. Possibly it might also be because of the recording equipment running, or because like all the other teams are running right now. This has happened twice during the week, and it did not happen in a deterministic way.
One more try. Okay. It's a landing. This is good. Cool. So I've seen two good unit tests. And here I can see now, this is great with the runway, but that was a very hard problem.
Yeah.
With all the frames that you're losing, but you did it.
Yeah.
Okay. And you don't know why it worked this time, right?
I think that everything is perfect because one suggestion to this part, it's worth to just have a cache of the map. I actually see not two unit tests. I see the whole story.
No, if I put this
Success.
together, I saw the
Yeah,
whole.
it's-
I saw the whole system test. Yes. Modular programmer would say there's a method called look for other passages, and a method look for traffic line or the traffic lights. Right. Congratulations. We're going to the next two victims, and we'll see what happens there. Then let's go.
First test case is to orient in Taki town, find airport, come back to airport. Now I just would like you to choose any correct place on the Taki board.
Is it right enough?
Yeah, it's fine. It should take itself. Well, now it's come to unobserved node, to unobserved intersection, and find that it is T-type intersection, comes from the down place and have two directions to move.
This is currently the map creation process. It's trying to show you.
There will be three linked nodes, three linked intersections. Well, I think it will recognize this direction, just taking in account that this direction is the first one.
Okay, what I don't understand, I thought you constructed the map already before the demo.
Yeah. And see it rotates in the another position.
We are explaining the process, how we are doing it.
It's not a map in the canonical view, it's just links between nodes. You can see it in a picture. And you know, for example, intersection 1 is in the middle. Intersection 1 is T down. For example, if we go down, we will go to node number 3.
As soon as the DuckyBot reaches the airport, the drone will lift up and fly there. Well, inside the Duckytown, but we count the airport as some kind of intersection as well.
Yeah.
That we know, okay, from this node and from this node we can reach it. And therefore, if we now change the position of the airport, we would have to create a new graph to actually find the
So
airport
your
intersection.
cache is.
It now recognizes that it is on the intersection. Now it comes to an airport.
It was an angry drone.
Yeah, we implemented facial recognition. What we can see is I pushed the drone towards the DuckyBot, and as we reached the correct location, the drone began descending. And the descending started completely automatically, so our computer vision part was working. So that the metal part is here, and the camera is here. When the camera is exactly above the QR code, the drone will pick up the ducky.
You can actually see that we most often detect the QR codes that we need. If we're ascending, we will detect the airport and will stick the duck towards the metal plate on the airport.
Try it again.
An important part worked.
Yes. All the ingredients were there. But the end, actually, I don't understand. It was pretty close. Why would you still correct it?
Yeah,
You didn't
it's
trust
still,
it?
no, it's still, so the thing is what I felt when I moved the drone towards the airport, it pushed back away from the airport. So it was still in the hovering mode where it tries to hover in one single place because it doesn't receive any commands.
I'd like to point out two things. You moved to the target environment, plus point. You did a push notification, another plus point. You were treating the drone like a handicapped person, minus point. But that is a bug that you could not fix, and you have still no idea where it could be and why.
So
It might have to do with the drone in an indoor navigation. Right? Yes, go ahead.
we found several times in the forums, even from the DJI official forum, that they said when you're using the SDK, the whole movement of the drone suddenly stops and it doesn't even take any commands from the controller.
I think I see now the second day where we gave them a hard problem and they solved it.
Definitely.
Okay, so now let's go to number 3. Let's see what's behind this door.
You will really be impressed.
And you get some surprise for them.
So the scenario will be take off, take a picture,
Who's taking off?
drone.
Okay. Show it.
So let's go.
Firstly, it recognizes the sign to know which way he can go and which way he can't go. If it recognizes sign incorrectly or something, and server replies with an error, it just starts randomly calling and finding the destination by itself.
Okay. And then it stops, and now it should recognize the stop sign. So it's now waiting for the drone. We have to do this as soon as possible, you know.
That's quite true.
It was much.
Wait, what's it called?
You still can make it.
Let's go now again. But can you slow down the movement? The speed. Yeah, that's how gentle.
That's how it's supposed to be.
So actually, this is not the airport though. So what? How close were you computation-wise, or why did it stop right there?
We kind of have a follow a mark or flight towards a mark mechanism, which we can show. It's pretty slow because we don't want to kill someone, basically. But the idea was, we have the coordinate system with the marks, right?
Okay.
So what kind of information can we get out of there? We can get a vector, a 3D vector, from the mark to the drone. Out of there we can get all three, or actually a lot of, three angles from the mark. So there's an alignment, which we call. There's also an angle, which basically you can see it here. So if the drone is high in the air, it can measure the angle from that vector to the mark. We were thinking of first fly with a static height and fly to above the mark. I know that it was a big obstacle with the drone, so especially the SDK was kind of a black box. So a couple of hours or one night was spent just figuring out what the SDK does.
Can you explain the motor? Because that was very creative.
You only need really one freedom of movement to pick up such a ducky, and we thought a grappling fork, if you say so. This is a microcontroller, it's called ESP8266, and it has, as you can see here, the little Wi-Fi antenna, so that was connected to our routing controller. It controls this absolute angle motor via a pulse width modulation signal.
You use the library call to do that?
The JSDK do not have much documentation. So we have this really simple interface, and you have some kind of comments, for example, gimbal adjust. If the drone sees a mark, it will automatically adjust its angle to it. I kind of only see it when it moves, so I'll just move it like this. And it goes up, and
can you go over it?
Yeah, sure. Yeah, that's probably best. Yeah, and, the idea is fly with the drone and then zero in to the orientation and position in X and Y.
Yeah.
Like this. Put the ducky on. Why?
It was good. It was on a good path, right?
But you could see like the drone like followed the mark with the
Yes,
gimbal as
it
well
was
as
on a
the,
perfect path.
yeah.
And then suddenly it
And
dropped.
it's a bit insecure.
Okay, it's good. It drifted always to the left. Okay, let's continue remotely. This is a great project, and you've done a great job. I definitely like your pickup and release mechanism. So I would consider this a success. Or a paper where we say this is a great education experience. We had 3 teams that did multi-systems approach. Each of you had a unique pick-up and drop-off mechanism. I think the Ducky Town, we also saw different ways. One team actually used the cache, again, defined some action items. And the last action item tonight would be, let's go for dinner, right?